Hello and welcome to the Wednesday, February 25th, 2026 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Graduate Certificate Program in Cloud Security. Well, one thing I noticed today was that our honeypots have been seeing recently a big increase in the number of scans looking for open redirects. An open redirect is a feature in a web application where the web application redirects you to another site without any regard as to where the user is really being redirected to. And it often happens as part of login pages where you would like to, for example, direct a user to the page they originally attempted to visit, and all sorts of click-through counters and similar features that often use redirects and with that are susceptible to creating open redirects. There are a couple of problems with open redirects. So an open redirect is basically a redirect where you're not really filtering what page you're redirecting the user to. The receiving page may then, for example, receive URL parameters, but could also be used for phishing. One spot where this has been particularly sort of a little bit of a problem lately is with OAuth 2, where during sort of the initial credential flow, where you are authorizing a site to use a particular service, the site's then being redirected back to the client that's attempting to use these credentials, but if net hacker is able to swap that redirect URI for a URI that is vulnerable for an open redirect, the attacker may obtain credentials, and that sort of bypasses some of the protections that sites have put in place to prevent these changes of the redirect URI. So it's certainly an important vulnerability. It's not currently sort of part of the OWASP top 10, but OWASP has a great sort of cheat sheet about open redirects and how to prevent them and why they are a problem. Also interesting here, pretty much all of the requests that sort of are responsible for that peak over the last few days, they came from one IP address associated with IP volume. IP volume is often referred to as a bulletproof hoster, meaning that they're not really all that eager to follow up on abuse requests and are often providing shelter to some illegal activity. So you may want to take a look at whether or not it's appropriate for you to block their AS. And talking a little bit about web application security, we do have an interesting new development here from Mozilla, from the Firefox team, and that's support for setHTML. setHTML is part of the Sanitizer API, and that's a standard that's supposed to make it easier to prevent some cross-site scripting attacks, in particular, so some of these DOM-based cross-site scripting attacks that have been particularly difficult to sort of prevent in some modern applications. The problem here is that we often use JavaScript in order to insert unsanitized text into an HTML page, and then of course you are opening yourself up for cross-site scripting. What the Sanitizer API and setHTML does is that it basically doesn't allow you to insert unsafe HTML, and that's in particular anything that's related to JavaScript. It comes with a default configuration that's pretty good, but you can basically define also your own configuration and which particular HTML tags and attributes you are allowing. Pretty easy standard to implement, in my opinion, and it's sort of tries to basically balance the two ends we had so far. We had innerHTML, which of course was horribly unsafe and that led to a lot of these problems. And we had inner text, which didn't allow any HTML at all. So with setHTML, you still are able to use markup, just no JavaScript. There's also the idea of trusted types that's also supported. setHTML at this point in the Sanitizer API appears to be only supported in Firefox and Chrome. So Safari is still holding out here. Haven't really found anything quickly sort of when Safari, if Safari is going to implement this. once I think Safari does, then this becomes a real usable standard to actually integrate in your web applications. Well, you know how it sometimes goes. If there's a vulnerability in a particular piece of software, we then have people look closer and find additional vulnerabilities. There's a second pretty bad and interesting telnetd vulnerability. Remember, we had like a couple months ago the one with the -f, where basically command line parameters were easily passed to the login shell, and then you could essentially bypass authentication. This second one isn't quite as bad. It's really more a privilege escalation vulnerability. But the root cause here is that Telnet also is able to set environment variables. And some environment variables can be used for authentication. In particular, one pointed out here in the bug report by Ron Ben Itzhak is the credentials directory. Credentials directory is basically where you find credentials, and if an attacker is able to create a file essentially anywhere on the system, they're then able to log in as any user, including root. So that's the problem here. Pretty interesting vulnerability, as I said. The workaround, apparently some versions of Telnet have implemented this, but the workaround here is that you only allow very specific environment variables to be set. There are couples that are useful, like language and things like that, and encoding parameters and such that are useful and that Telnet does routinely set. And the solution is to just limit it to these specific environment variable. Apparently, others have just basically set up block lists of environment variables they don't allow. And then, of course, people just come up with a different way to set the same environment variable or another environment variable that they may have missed that some systems are using. Well, and that's it for today. Thanks for listening. Thanks for liking. Thanks for subscribing. And special thanks to anybody leaving a good comment with your favorite podcast platform. And talk to you again tomorrow. Bye.